Hello and welcome to this 14th Dyalog Webinar, this time on our new support for Jupyter Notebooks. So what are notebooks at all? Well, at first glance, a notebook looks very much like any other document that you might see in your normal word processor or say a PDF file in a reader. The difference there is that not only can the notebook contain formatted text and other content, it can also contain code, programming code, which can then be executed right inside that document. And then the result is displayed inside that document in line with all the other content. And the result of such expressions can even be rich. It can result in some HTML that gets rendered and displayed right inside the document with everything else. So this makes it, in a sense, as powerful as a text document, a formatted one, and as powerful as an interactive programming session, like the traditional APL session, but all in one neat package. So here's an example. Jupyter Notebooks are traditionally using Python. So this is a Python notebook. And we can see in here that we have some formatted text at the top, we have some code, and the result of the code is this nice map at the bottom. And so the new thing that we're presenting here with this webinar is that we can also do this thing with using Dyalog APL. So again, we have formatted text at the top, we have some code, we have some results, some more code, and finally a result that gives us a nice chart at the bottom. Why would you want to use notebooks at all? Well, there are many different ways it could be used, and there are several different benefits you could have from this. So as I mentioned, it's a single document, as opposed to a traditional way of having academic papers with notes referring to an implementation of the idea stated in the paper, and the other end where you have code with comments possibly referring to various papers on the subject of that the code is implementing. Here you can just deal with a single document, a single file, where everything is in one place and there's no need to look back and forth between various pieces of the picture. So this is good for, say, research papers. It's good for explaining how you do things, how you got to a result. It's good for instructing people on how to do things, whether it is a way to calculate certain things or how to use a certain tool, or even just using the programming language itself. So it can be used for training and information purposes. Specifically, Jupyter Notebooks, why those? Well, notebooks started with Mathematica a long time ago, and since then there have been a lot of different notebook formats, but they've always been tied to a specific product, a specific programming language, a specific environment. The Jupyter Notebook is special in that it's the first such notebook project that crosses the boundaries between various programming languages. Indeed, there's an organization, Project Jupyter, that is working on this purpose of making this as widely available as possible. And as the name indicates, it began with three core languages, Julia, Python, and R, forming kind of the name Jupyter. But it has since grown, and it's easy to extend with more languages, and there are now over 100 so-called language kernels that can be used, implementing functionality for more than 70 programming languages. And so this is why we at Dyalog have chosen to also join this Jupyter system. And there are a lot of scientists out there that are very, very excited about this and are switching over to using this as their basic format for pretty much everything they do. But it can be used in many different ways. I'll show you some of what you can use it for as well. There are several different ways to use Jupyter Notebooks. The traditional way is to install the entire Jupyter system that runs a server that you're just using locally from your local browser, and the server then serves up the notebook. But you could also use an online system, and then you don't have to have anything special on your computer. Then you can save the notebook, including results from the execution of the code. And then any notebook viewer, Jupyter Notebook viewer, can view this, even if it doesn't have the specific programming language capabilities that your notebook requires. And then from there on, you can also export to any format that you need, and that can then be used for publishing, whether online or in print, used like any other document. I'll go into the details of each of these modes. So, how does that actually work underneath the covers? The traditional, again, the Python usage is that we have a Python system running on the computer, and the Python system runs a web server. The web server uses a language kernel that acts as the glue between the server and the interpreter that's actually evaluating the code. So from the browser makes a request to the server, and the kernel may take care of some special cases, but eventually sends code to be executed by the interpreter. Interpreter sends the result back, and the server sends back the output to the browser, where you, the user, can view it. And it works exactly the same way when it's talking up with APL. So we still have Anaconda and its notebook server, but now we have a new Jupyter kernel for Dyalog APL, and that communicates with our regular interpreter. And so we have a web browser sending the request to the server goes to the interpreter back to the kernel, and the server gives you back the result. What's interesting to note here is that the Jupyter kernel and the interpreter, they speak with each other using the write protocol. That's exactly the same language and pathway as the write interface uses to speak with the interpreter. So here we have another example of how valuable it has been for us to have this communication protocol that allows a remote control of the interpreter. In fact, the Jupyter kernel was originally implemented by a third party and required no knowledge of APL at all. You just needed to know how the protocol works, and that's enough. So potentially in the future, other people, other organizations can write their remote controller for Dyalog APL using the write protocol. When you need to run a Jupyter Notebook server, there are a few steps you need to go through. It's not very complicated. Of course, you need Dyalog installed, you need our kernel, and you need to have the Anaconda system installed. And then you just launch the Jupyter Notebook as a server, and that's it. You can always find these instructions at the address that's at the top of every screen that you see here. If you haven't noticed it, now you will. Let's try it. So here's our wiki that has all the information that you need to get up and started with this. And what we're going to do now is run this offline server. So the first thing, of course, is to install Dyalog APL. You should be familiar with this by now. And then we have to have Anaconda installed. It's as simple as downloading the installer right there. I won't install it right now because I already have it installed. And then we have to get the kernel set up. So download the kernel. And once you have that, you just run the appropriate script for your operating system. That's it, a blink, and everything is installed. And now, since I'm on Windows, I can find Jupyter Notebook on my start menu. And starting that opens my browser with a page that's being served by this Jupyter server that is running in the background. You don't actually see it. It gives me a file listing of what's actually on my computer. There's no security risk in this. It's just running locally. Nobody from the outside can actually access this. And I can then navigate to any notebook that I have and open up. So here is what an actual Jupyter Notebook may look like. You can see that we have some formatted text at the top, and then we have some code, and it keeps going like this. So there are these cells that we can go through. Some of them are text, some of them are code. And I can then go up here in the menu and choose Run all the cells. And we get all the output as we goes along. And at the very end, we get a nice chart. I can go up and I can change things. So let's say we want more data here. And I can choose to run everything from here and down. There we go. More data points right there. I'll show later how we create a new notebook and edit it and create content inside it. Then I mentioned that we can also use online notebook servers. So generally such a server is for one or very few programming languages. And so here's one for Python. And very soon we will also launch TryAPL's support for running Jupyter Notebooks. We are currently working on it. And we are also adding more lessons to TryAPL. All this you can find out more about at the TryAPL presentation at the user meeting in Belfast. So stay tuned for that. The benefit of using an online notebook server is of course that you don't have to install anything, though you may need to sign up for the service. You won't have to sign up for TryAPL, don't worry. And on the server side, they then have to worry about security. So such servers will generally have some restrictions. Either they will run the notebook in a sandbox, limiting what it can do, or they will have white or black lists on what the code is allowed to do. And this will be the case on TryAPL, as usual with TryAPL code as well. And do note that notebooks can execute any code that you're allowed to execute in that programming language that's running, say APL. So be careful. You don't have to worry about running things locally on your machine, but if you consider setting up your own server for others to use their own notebooks, then make sure to take proper precautions and not to expose your system. Then there are static notebook viewers. They are of course very safe. So a Jupyter Notebook is really just a JSON file with a different file extension. And with code cells, you can have stored the result from last time the code was executed. This means that any Jupyter Notebook viewer can render the entire Jupyter Notebook, including results from the code. It just can't change anything or re-execute anything because it has no programming language execution engine behind it. There are online systems that include Jupyter Notebook viewers, so if you put a Jupyter Notebook on GitHub, it will render you a preview there. That's pretty good. And the Jupyter project has its official viewer as well and has a very good rendering. It looks pretty much like in any offline system running. Then you can export your notebook, and it can go to all the formats you would want, but some of them you have to install a certain tool to export to that format. You can always go to HTML, and then you can export further from HTML to whatever you want, so you're ready for publishing. Should be unnecessary to mention that, of course, such exported notebooks, you can't change anything. They're just like any other hard document. Okay, now let's create a new notebook. So we can go back to the interface we had before, and we can choose here to create a new. We have the choice among the installed language engines language kernels. So we want to create a Dyalog notebook. And so as I said, there are two different types of cells that you should be worried about. There are code cells, and we can choose Markdown. Markdown is a formatting system that just uses plain text. It's really, really simple. It uses some of the unusual characters on your keyboard to indicate how you want text formatted. You can just use it as plain text and it will render nicely anyway. But you can also learn a couple of the tricks that Markdown has and get some nicely formatted text this way. Many of the ways that Markdown uses are similar to what people would do in, say, chat if there's no formatting available. So, for example, let's create an academic paper on arithmetic mean. So I put a hash at the beginning of the line, and that means a heading in Markdown. If you want bold text, you can put double stars around the text. And if you want italics, then you can put single stars around. And you can see that the interface here hints at us that this is going to be bold and this other phrase is going to be italics. To create a new paragraph, just make a double line break in between. Okay, and then we can render this cell of text with the run button. And then the default cell is the code. We can switch this to Markdown. And there are a lot of keyboard shortcuts. All of them are available up here. I won't go through that now. Let's create another one. Right, now we have a fine academic paper on arithmetic mean. Now we can go ahead and also implement the code for this. So I'm going to insert a cell below, and that's a code cell. This is the APL code that implements the text that we have above. I can execute this. There's of course no result as we're just doing an assignment. Same thing here. And finally, we can get our output. Right. Now we can go and play around with our formula and output this. And then we can go and say I want to run everything from here and down. Let's fix up this. We can just run all cells. And here we get our result. Okay, let's give it a title. And we can save it like this. We can also, right from in here, create a new notebook. This time, let's have a look at more rich output. So to format code that is being showed inside a text cell, we use backticks. Note that this code doesn't get executed. It's just a way to format it as code. And now let's create some HTML. So here's first a header, a heading. We could of course write an entire program that generates it for us, but I'll just handwrite it for now. And then, as part of the Jupyter kernel that we have, but it will also be part of a future release of Dyalog APL, we have a special user command that tells the system that I don't want the result, this HTML displayed, I want it rendered as HTML. And you can see that even when we have an error, we get a nice highlighted message back in the format that is familiar to you as an APLer. So we can re-execute this. And here we get a greeting and a paragraph below it. We can insert styling as well. And re-execute that. And we get a nice red paragraph. We can also use external files, style sheets, images, and so on. As long as they are in the same directory structure as the notebook itself, we can get to them. Okay. Not only can we use HTML, we can also use SVG directly without having to embed it in an HTML document. The system will recognize this. So let's create a circle. And we're going to make the center X coordinate at 200 and the center Y coordinate at 70. And the radius, we're going to make it 60. And let's give it some color. Right there. We can render this. A nice orange circle. Let's change the color to something a bit more appropriate. There we go. So this is the HTML user command that comes special for this. There's a second user command that I'll show. But first, there might be things that Markdown can't do for you. And then the text cells also allow you to put raw HTML right inside the text, and that just gets rendered as HTML. So for example, Markdown doesn't have superscript, but HTML does. So this is a superscript tag. You can see we even get syntax coloring for HTML. And we got proper superscript here. So let's generate some data. Here are some X values. And some Y values. And then we have this new other user command. Again, part of the kernel, but will be part of the main product as well in the upcoming release. We're plotting Y against X. And we get a nice chart like this. Of course, we can just go up and change our data. Zoom in on the graph. Not only can we do line diagrams, but we can also do, say, a bar chart. we have this modifier. So here's a bar chart. For now, the plot user command doesn't let you modify any details of the chart. Just lets you select the type of chart, but we may add features to that in the future. And it uses Chartplot underneath the covers, and that means all the chart types that Chartplot has are available here as well. In fact, you can just change this to a pie chart, and we get a nice bar chart. You can also ask the user command, what are all the chart types? These are the chart types. So quite a lot of options there. And we can get details about a certain chart type. And so we get some information about it and information about the syntax it takes, what the data that it takes as argument represents. Again, HTML and plot user commands will be part of the main release. You will be able to type that right into your APL session. So to go over it again, these are the ways that you can use Jupyter Notebooks. You can either install it, run it as a server locally on your computer. You can use an online notebook server. You can store it with or without the output, then open it in any viewer, send it to anybody who can use any viewer to open it, or you can export it to any format you want. Now is a good time to ask a question on the live chat. You can find all this information on our Jupyter Notebooks wiki. If you have any issues or ideas, if you have notebooks that you want us to have a look at, possibly even include in the future on TryAPL, then by all means send them to us. I also like to take the chance now to say thank you to people that have been involved. Technology partnership with the ones that originally implemented the kernel, the APL kernel for Jupyter Notebook, using the right protocol. And our summer intern, Will Robertson, and did an amazing job working on the kernel, refining lots of points in it and fixing various issues. And he has also created a good many notebooks that you can find online. By the way, if you are interested in internship at Dyalog, let us hear from you. A thank you also to Gil Atharaya from Optima. He made the syntax coloring work inside the code cells. And finally, thank you to you for watching. And see you back in future webinars.